Hello everyone, welcome back to the third part of the creating toolpad with Woodbee. So in the previous part we created rough cut using the planar sheet component in Woodbee, and we basically removed the material approximately 2mm with a 2mm offset from the object. And now we're ready to plan different strategies to mill the faces of our object exactly, which is the fine cutting. To do fine cutting, I'm going to copy both tool and the planar sheet component. And let's say copy paste. So we have, I'm just duplicating them, and let's get that component for now here. We don't need it. So now we can from here, from rough milling, switch to fine milling down here. So I'm going to turn off this one, and we're going to look into fine milling. In the fine milling section, we have different options. We have different strategies such as 2-dimensional contouring, 5-dimensional contouring, or surface milling. And each of these strategies, if we enable them, they're going to look into our geometry and see what parts of the geometry, what surfaces of the parts can be milled using that particular strategy. In my object right now, I have different features. That some can be milled. For example, this pocket can be milled using a 2D contouring. That's a simple one. This area, this reveal, can be created with the surface milling, because we're gonna just move the tip of the tool, if we have a flat tool, over the surface in order and get the surface that we want. And some other features that we have, like these slanted faces, they can only be milled using a 5D contouring, because the tool has to go along the face and continue all the way to the other ones. So it needs to have a 5-axis machine in order to tilt and keep the tool tangent to the surface. So each of these strategies is going to create a toolpad from different parts of our geometry, and at the end we need to combine all of them into one single toolpad. Okay, so the first thing we want to do is to change our tool so we can use it for these tiny details. I copied this from the tool which I have created for the rough milling. So for now I'm just going to assume that is a 5mm drill in the same holder as the rough. If you have to change the holder for your fine tools, you have to just repeat the steps for creating the holder here and use it as a separate set of numbers for this tool holder. Okay, so let's go ahead and turn on, for example, the 2D contouring. And let's connect that to our simulator. I'm going to replace that with a fine cut for now, but later on we can actually add all of them together in the same simulation. So right now I can see a bunch of toolpads that are generated, and these toolpads are only generated for those features that can be basically cut using a 2D contouring. A 2D contouring is essentially a simple contouring where the tool is always perpendicular to the plane, so it does not have any rotation as such. So because these faces were perpendicular into the plane of the milling, each one introduced a toolpad. And this toolpad is extended all the way to the top, where you can see because right now this edge is shorter than the upper edge, but the toolpad follows the upper edge. This is why on this case it's the other way around, where the lower edge is actually longer than the upper edge, but the toolpath has followed the lower edge, whichever is longer, basically. So if I run the animation here, you can see the tool is moving from one face to another face, and it just milled the particular face, and it comes back to a safe plane and moves to the next face. This makes the toolpath very long, and also the whole operation is not efficient. In order to fix that, we can basically use one option here, which combines the faces that are coplanar and just make one single toolpath for them. So if I click on that, you can see now I've got much simpler operation. And go back to our simulation, and the drill just move along the faces, in this case these three faces, and then do the milling, and then goes to the next group of faces. Now in the next step, I'm going to copy this component again, and using the same tool, we're gonna turn off the 2D two-dimensional contouring, and instead we're gonna turn on the 5D contouring and connect that to the operation channel. Planar sheet component automatically detected the faces that can be milled using the 5D contouring strategy. And those are the ones that are that you can see here. Well, let me just turn on the animation again. And now tool is gonna move. Let's just slow down a little bit, see how the tool moves in these pockets. So it's just moving tangent to the faces and mill those features by the side of the tool. Okay, so just one thing that I missed here is that I'm using the rough tool, the tool that I use for rough milling, still in my simulation component, which is wrong. When we are changing the tool in the operation settings, we have to also use the same tool for the simulation. So I'm going to change that now, and then you can see now a more precise simulation with the updated tool.
So the last thing we want to do is to remove the material around this object and create that reveal. In order to do that, we assume that our drill has a flat head, and then we're going to use that drill and remove that over the surface in order to remove the material from this part. And this is something we can do with the surface milling, which basically moves the drill over the surface, keeping the drill in the direction of the normal in that point. So that means if we move the drill perpendicular to the surface, we're going to remove the material from this part within this area of the reveal. So I'm just going to copy this again, and we're going to choose surface milling instead of 5D contouring, and we connect that to our simulator. So as you can see, this component has automatically detected where where it's possible to mill using the tip of the drill, and it has created the toolpath. And we're going to look at it once. So it just moves perpendicular to that surface and remove the material. However, I think we can do a better job by choosing a bigger drill, because now we have a long toolpath since the drill is only 5 millimeters, so it has to offset every 5 millimeter. If we assume that our drill here has also a flathead, then we probably can just use this drill to do this operation, and it's going to be faster. So I'm going to just try to turn on this operation here in the rough cutting stage, and we're going to see if this will reduce the tool path. So now I'm having the same tool and also added the surface milling here. And you can see now it's much shorter tool pad. It's just 2 passes. So the way it works is it first just mills around the object, does the rough cutting, and goes into the hole, and then comes back and mills the surface. All right. So to wrap up our tutorial, we basically have 2 operations. In one operation, we're going to use 10 millimeter drill, and we're going to use that drill to create the raw part. And then we're going to use the same drill to mill that surface here. So this will be one group of operation. And now, just to simplify everything here, we can delete these other 2 components and just have the 2D contouring and 5D contouring in the same component. And we're going to use the smaller drill for the fine cut. So this would be our rough cut, and this is our fine cut. We're going to create a toolpad with the fine cut operation and the fine cut tool. So, all right. So this shows now the entire milling operation that includes both fine cut and both rough cutting and fine cutting. So the important thing is that you need to use a toolpath generator where you have different tools, because each one will accept one single tool. Okay, so that's it for this video. We're going to discuss further details in the future videos. Thanks for watching and see you next time.